Example 3. Critical thinking, sales of vinyl records. Listed below are sales millions of vinyl LP units in the United States. The sales numbers are listed in order by year beginning with 1993. For part A, they want us to use the listed sample to construct a 95% confidence interval estimate of the population mean. So what we're going to do is we're going to first not check the requirements yet, and you'll see why in the next question in part B, but let's first find the critical value. Well, since we're constructing a 95% confidence interval, okay, what we want to do first is to take the value of 1, because that's going to be alpha, 1 minus 0.95, which is the percentage of the confidence interval, which gives us 0.05. Okay, and then number 2, we're going to take that alpha and then divide it by 2, which is 0.05, and then dividing that value by 2 gives us 0.025. And then we're going to be able to figure out what is the critical t value with that area. So if we draw our bell curve, okay, so our bell curve is going to have on the t scale 0, and then we want to find the area to the right of that t alpha divided by 2. Well, this area represents 0.025. So to find the area there, we could either use the table or StatCrunch. I'm going to go ahead and use StatCrunch. So putting in our data for StatCrunch, so we have stat, we're going to go to calculators and then select T. And then we want to put in our degrees of freedom. Well, we got to find out what our degrees of freedom are. So for the very first one, we know that when we add up the total sample, so the total sample in here, n is equal to 26. So to find the degrees of freedom, it's equal to 26 minus 1, which is 25. Okay, and then we want to have the area to the right, so we want to have greater than or equal to, and we're using 0.025 to then determine what is that critical value. So here we're putting in the degrees of freedom to be 25. We want to make sure it's going to be greater than or equal to, and we're putting it in the area so that we can find the critical value. So we're putting in the area over here, 0.025, and then that gives us the following value. So there is our critical value, and we want to round that to 3 decimal places. So if we round it to 3 decimal places, then that gives us 2.060. So therefore that is the critical t value. Now what we want to do is we want to find the mean and the standard deviation of the data. And that means we want to find the sample mean and the sample standard deviation. So what we need to do is we need to come in here and we need to enter all of these values into StatCrunch, which I've done, and we're typing it LP. So now what I want to do is I'm going to go to Stat, Calculators, and then go to, Stat, Summary Stats, and then go to Columns. And we're going to select the LP column and select the mean and the standard deviation. And now we're going to go ahead and select Compute. So let's take a look at the values that we got from StatCrunch. Okay, so I know that in our problem here, we go to 1 decimal place. So we're going to go 1 more for the mean. So we're going to put 3.97. But as far as the standard deviation is concerned, I'm going to round that to 6 decimal places just because it always gives me a better number. And I think it's just important to do that like we've done in the past. So we're going to put the standard deviation to be 4.837666. So now we want to be able to find the margin of error when we have the critical t value of 2.060 the standard deviation to be 4.837666, and the sample size to be 26. So we're going to plug in those values. So we plug in those values, we get the following. The critical t-value is 2.060. We know that the sample standard deviation is 4.837666. And we know that the sample size is going to be the square root of 26. So let's go ahead and do that. So on our calculator, let's go ahead and do that. We have 2.060 times 4.837666. Okay, and then we're going to take that value and then divide it by the square root of 26. And that gives us 1.94413. That's to 6 decimal places. Okay, now in step 4, what we want to do is construct a confidence interval where the sample mean is 3.97 and the margin of error is 1.954413. And then we're going to plug it into the formula. So we know the mean is 3.97, and we're going to subtract 1.954413 on the left side, and then 3.97 plus 1.954413 on the right side. We end up getting, rounding it to 2 decimal places, we get 2.02 million on the left and 5.92 million on the right. Okay, now the next question says, is the confidence interval method described in this section, in this particular section, a good tool for gaining insight into the nature of the sample data? Well, let's go back and then take a look at this, because we did not check the requirements of this to make sure that we would proceed. So in this question, it's given us an idea as to whether we would have proceeded to find the confidence interval. If we go to graph and then select QQ plot, select our column, put in horizontal and vertical lines, and select compute. If you look at the data, this data is not a normal distribution, and our values is below 30. So therefore, this would not have been a good tool for this particular example because of the fact that the graph does not represent a normal distribution. So a check of requirements will show that the sample is small, so it's not greater than or equal to 30, and the data do not appear to be from a population having a normal distribution, so the requirements are not satisfied. So the confidence interval is not a good tool for gaining insight into the nature of this particular data. Now, for part C, apart from the confidence interval, is there some other tool that would be better for gaining insight into the nature of the sample data? And what is the most notable about the sales numbers? Well, because the sales numbers are listed in order by year, a time series graph should be helpful in revealing the nature of the data. The accompanying time series graph, which we've seen there, clearly shows this notable feature. There is a distinct pattern of increasing sales over recent years, and this shows that the population is changing over time, but the confidence interval does not reveal that trend. This also shows that instead of blindly just applying statistical methods, we should always think about what we are doing.